Good morning, this is your Stat Sensei, Mr. Spensei. This is Death Packet Unit 3B, problems 81 to 90 on probability distributions. So the distribution of weight of 16-ounce potato chip bags is normal with a mean of 16.96. So we have a mean of 16.96 and a standard deviation of 2.31. If 50 random samples of 12 bags each. Okay, so my sample size is 12. We don't care about how many times it repeats. This is a sample size. Are picked and the mean weight of each sample is found. Which of the following is most likely to represent the distribution of the sample means? Well, they told me it was normal, so that gets rid of A and B right away. It's not going to be skewed because the underlying distribution is normal. If the underlying distribution is normal, then the sample will be normal. All right. So I need to figure out what my I'll check my mean. Well, mean 16.96. That's close to 17. That's close to 17. So the mean's not helping me out. So then I need to check the standard deviation. Well, the standard deviation of X bar, the sample means, is the standard deviation of the population, which is 2.31 divided by the square root of 12. So 2.31 divided by 12 raised to the half power is 0.666. Oh, that's nice. So the standard deviation of X bar is 0.666. Now, we should have basically three standard deviations above and below the mean, at least two. So let's go 0.666 times 3 and add that. Oh, so 2 and add that to our 17. 17 plus 2 is 19. That's up here, so this isn't looking too good. And 17 plus 9 is here. And it's like, oh, there's no way we have this one. We're not going to have two above because this is going to be three standard deviations wouldn't have all this information out here. So let's go back and check this and multiply by two standard deviations. So 16.96 plus 2 times our standard deviation. That's two standard deviations. Oops. 16.96 plus 2 times our number of standard deviations, which is 0.66. And we end up with 18.29. 18.29, that's about two standard deviations. And if we take the 16.96 minus 2 times, we end up with 15.6. So this is pretty close because if you remember, if you think about it, we have 99.7% within plus or minus 3. So 1 minus 0.997 divided by 2, that means we'd only have 0.0015. We're not going to have very much here. All right. So this is probably our best estimate. All right. This is probably our best estimate. Because if we say how much would we have beyond two standard deviations? Well, 95%, so 0.95 divided by 2, oops, 1 minus the 0.95 is 0.05. Divided by that, we'd have 2.5% out here. And I was like, yeah, if I continue that curve on, that's probably 2.5% out here. So D is probably my best guess. Okay. All right, number 82. Car insurance policies for teenagers have higher premiums than for adult drivers because teenagers are considered to be a high risk population. Suppose the average yearly cost of teenagers ages 16 to 19 insurance is 3,025. So they're telling me the mean is 3,025 with a standard deviation of 430. Is there sufficient information to answer either or both of these questions? What's the probability a randomly chosen teenager pays over 3,000 a year for auto insurance? All right. So the problem with this one, is to be a individual, I need to know that the underlying population is normal. They did not tell me the underlying population is normal, so I cannot assume that it is. So there's not enough information for this one. For number 2, what's the probability the average amount paid by a simple random sample of 50? Oh, when it's a size of 50, that's n equals 50, that's greater than or equal to 30, then I could do this by normal by central limit theorem. So this is possible. So I can do 1, but I can't do 2. So sufficient information to answer question 2, but not question 1. So our answer choice is the C. And once again, the reason I can't do the first one is they didn't tell me what the underlying population is, and my sample size is, it says A randomly chosen. So my sample size is 1 there. All right, number 83. Which of the following is incorrect? The mean of the sampling distribution of X bar is equal to the population mean, even if the sample size is small. That's a true statement. The mean is the mean is the mean. So we like that's a true statement. And we are looking for incorrect. Regardless of the sample size, the sampling distribution has a standard deviation of the standard deviation divided by square root of n. Sampling distribution of X bar, that is 100% also true. The sampling distribution of X bar is normal no matter what n is if the population is normal. 100% true. If the population is normal, the sampling distribution is normal. When n is large, the sampling distribution of X bar is approximately normal, even if the population is not normally distributed. They said n is large. I prefer them to tell me that n is greater than or equal to 30, but that sounds pretty good. That sounds pretty true. So we'll look and make sure that it's not a better choice. All right, the standard deviation of X bar gets closer to that of the population as the sample size increases. No, it doesn't, because the standard deviation of the population is that, while the standard deviation of X bar is the standard deviation divided by the square root of n. So this remains the same, but as n gets bigger, this gets smaller, it gets farther and farther away. As the sample size gets bigger, this gets less close to being the standard deviation of the population. So 83 is 80. Number 84. The mean age of employees at a large corporation is 35.2 years and the standard deviation is 9.5. So mean is 35.2, standard deviation is 9.5. A random sample of 4 employees will be selected. What are the mean and standard deviation of the sampling distribution of size 4? Okay, the mean is the mean is the mean. So the mean is going to be 35.2 regardless. So I don't have to worry about that. All right, so that takes care of that one. The standard deviation is going to be, the standard deviation of X bar equals the standard deviation of the population divided by the square root of n. Well, 9.5 divided by the square root of 4. Well, the square root of 4 is 2, so 9.5 over 2. And this is our answer here. Problem with this one is it needed a square root sign. And the square root of 4 is 2. All right, number 85. Samples A and B were selected from the population. The mean of sample A is equal to the mean of sample B. The mean of sample A is equal to, A and B were selected from the same population. The mean of sample A is equal to the mean of the population. All right. The mean of sample A is a point estimator for the mean of the population. That's true. The mean of sample B is a point estimator for the mean of the population. Yes, because the sample mean is thought to be an unbiased estimator for the population mean. Then it says the mean of sample A is equal to the mean of sample B. We would like to think that that's the case, but if you take a sample and I take a sample, chances are we're going to have different values. So even though these are true, this isn't. All right. Your sample and my sample are going to vary. However, we always assume that the mean is the mean is the mean. So it's true for A and true for B, but not true for this one. So our answer choice is D, 1 and 2 only. All right. 86. The distribution of the number of siblings of students at a large high school is skewed to the right with a mean of 1.8 and a standard deviation of 0.7. Mean is 1.8, standard deviation is 0.7. A random sample of 100 students from the school will be selected, and the mean number of siblings in the sample will be calculated. Which of the following describes the sample distribution of the sample mean for samples of size 100? All right, so we have a large sample, so n equals 100. That's greater than or equal to 30. So it's the mean of the sampling distribution, or will be approximately normal. So it gets rid of the skewed. But the standard deviation of X bar equals the standard deviation of the population divided by the square root of n. So in this case, it's 0.7 divided by the square root of 100. So 0.7 divided by 100 raised to the half power is 0.07. And so it's not 0.7, it's less than 0.07. So our best answer choice is E. 87. The distribution of commute times for employees at a large corporation has a mean of 22.4 minutes and a standard deviation of 6.8. A random sample of N employees will be selected and their commute times will be recorded. What's the true about the sampling distribution of the sample mean as N increases from 2 to 10? All right, the mean is the mean is the mean. The mean doesn't change. So, but standard deviation of X bar, if I go from, we had a 6.8 divided by the square root of 2. And if I did the other one, 6.8 divide by the square root of 10. So 6.8 divided by 10 raised to the half power is 2.15. And this one's going to be much larger. 6.8 divided by 2 raised to the half power is 4.8. So as we increased our sample size, our variance or our standard deviation decrease. So the mean does not change and the variance does not change. No, that's false. The mean does not change and the variance increased. No, the variance decreased. Best answer choice is E. All right, the distribution of wait times for customers at a certain department of motor vehicles in a large city is skewed to the right with a mean of 23 minutes and a standard deviation of 11. A random sample of 50 customers' wait times will be selected. Let W represent the sample mean wait time in minutes. Which of the following is the best interpretation? The probability that X bar W is greater than 25 is 0.10. All right. So let's do this real quickly. Let's run a stat test Z test. Stat test Z test. And we have a mean of 23, a standard deviation of 11, a sample size, an X bar of 25, and then we have a sample size 50, and we need the greater than. When I do that, I get a p-value of about 10%. Okay, my probability is almost 10%, is 0.01. So this says approximately 0.1. It's really about 0.09928, but that's close. For a random sample of 50 customer wait times, the probability that the total wait time will be greater than 25 minutes is 0.1. I don't like that because this says total wait time, and we're not looking for total wait time. We're looking for average wait time. So I don't really like that. So I'm going to mark that one off. B, for a randomly selected customer, no, we're not talking about a randomly selected customer. We're talking about a group, the group of 50. For a randomly selected customer, no. All right, for a random sample of 50 customers, hey, that sounds good. Wait times, the probability that the sample mean customer wait time will be greater than 23 minutes is approximately 0.1. Um, problem with that is that's the population mean, and we didn't test that. We tested this. All right, we're looking at the probability that X bar was greater than 25. So that's the problem with this. Whereas this one is the same thing, except instead of 23 minutes, they use 25 minutes. And that is the probability that X bar was greater than 25. And remember, I said we need to have the word average. They use the word sample mean. So we're good there. So we like that. 89. The distribution of height for a certain population of women is approximately normal with a mean of 65 inches and a standard deviation of 3.5. Consider two different random samples taken from the population, one a size 5 and one a size 85. Which of the following is true about the sampling distribution of the sample mean of the two sample sizes? The mean is the mean is the mean. All right. And they said the underlying sample is normal, so both are going to be normal regardless of sample size. So both distributions are approximately normal with a mean of 65 and standard deviation of 3.5. False about that. The mean is 65. That's true, but not the standard deviation because the standard deviation is going to change. Both distributions are approximately normal. The mean and the standard deviation for size 5 are both less than the mean. The mean and standard deviation are both less. No, mean doesn't change. Both distributions are approximately normal with the same mean. The standard deviation for the size 5 is greater than that size 85. That's true because remember the standard deviation of X bar is the standard deviation of the population divided by the square root of n. So what's 3.5 divided by the square root of 5? 3.5 divided by 5 raised to the half power. And we get 1.56. Whereas if we have a size 85, 3.5 divided by the square root of 85, we end up with 0.37. Well, clearly size 5 was greater than that. So our best answer choice for 89 is C. 90. Only the distribution for size 85 is normal. Okay, so that's messed up. All right. Yeah. Mark E, we're missing a question on that one. Need to go back and fix that, figure out what's wrong. But that is completely, yeah, that's not going to work. Sorry about that. So we can ignore that problem. All right. So hope to see you on the next one. Thanks for watching.